All right, continuing with our study of probability. Sometimes we have what's known as mutually exclusive events. Two events in the same sample space are mutually exclusive if they have no outcomes in common. In a case like that, we would say that the probability of A and B both occurring is 0, and if that is the case, then the probability of A or B occurring is the probability of A plus the probability of B. So if events are mutually exclusive, we can add their probabilities together. Oh, and if events are not mutually exclusive, then the probability that one or the other of them occurs is the sum of the probabilities minus the probability that they both occur. Those common outcomes have to be subtracted out because we don't want to count them twice. So here's an example. What's the probability? We draw a card from a standard deck of 52, and we get either a 2 or a club. Well, the probability of a 2 or a club, since these events are not mutually exclusive, there is one card that's both a 2 and a club. We compute the probability of getting a 2 and add that to the probability of getting a club, and we subtract from that the probability that our card is the 2 of clubs. And that's pretty easy to do. There's 4 2s in the deck, so we have a 4 out of 52 chance of getting a 2. There's 13 clubs in the deck. We have a 13 out of 52 chance that the card we drew is a club, but one of those was both a 2 and a club, so we have to subtract that one, which gives us an overall probability of 16 out of 52, or 4 chances out of 13 that this is going to be what happens. Now, you try this one. Pause the video, see if you can figure out what it is, and when you're ready, come back. You got it? Okay, well, the probability that we're going to get a diamond or a face card is the probability that we get a diamond plus the probability that we get a face card, but there are some common outcomes. We have to subtract the probability that we get a diamond, a card that's a diamond, and a face card. So there are 13 diamonds out of 52 in the deck. So the probability that the card is a diamond is 13 out of 52. Add to that the probability that it's a face card. And you might remember from the previous example that there were 12 chances out of 52 that that was the case. And how many are diamonds and face cards both? Well, there's a jack of diamonds, a king of diamonds, and a queen of diamonds. So there are 3 of those. So we subtract 3 out of 52. So did you get 22 out of 52 or 11/26? If so, congratulations. That's about a 46% chance of that event happening. Okay, slightly different kind of problem. This one I liked. I drew from the book because I liked it. You'll find it in the book if you look. We have data on a human resources department of a company. Numbers of employees have been with a company for various periods of time, and the results are summarized here in this table. We're going to select an employee at random, and what's the probability that that employee has 4 or fewer years of service? Well, that's easy. I'll go over here and figure out A. We just simply look at the first entry in the table. Anybody who has 4 employees or less is going to be in that first group. So that's going to be 157 ways that that could happen. And there are a total of 529 employees if you add up all those employees. So that's about that's 0.297 roughly, so about a 30% chance of that. And then B, what about the probability of 9 or fewer years of service? Well, we've already figured the probability of fewer than 4. The probability of 5 through 9 is 89 out of 529. So the probability of 9 or fewer, since these events are mutually exclusive, the answer to part A and the answer to part B, you couldn't have more than 5 and also 4 or less years of service. So we can get this answer by adding this to the answer from part A. So we're going to add the probability of 0 to 4 and the probability of 5 to 9. And that's 157 plus 89 out of 529. Or, well, this is about a 0.46, approximately 0.465 chance that that occurred. And then one more. What is the probability that an employee chosen at random has 30 or more years of service? Well, we can add, I'm going to call this problem C. It wasn't a C, but I'm going to call it C. We can add the 30 to 34 group and the 35 to 39 group and the 40 to 44 group together, because the probability because the event that an employee chosen at random is in any two of those groups is impossible. So this is going to be a total of 72 out of 529. And that's about a 0.297 chance of that occurring.